All right, this is a video to show you how to do the midterm for the geometry final part 2. Here was number 1. First question was, how long is the hypotenuse? Hypotenuse is twice as long as what we have here, the whole hypotenuse. Here's your right angle. So your hypotenuse 15 times 2 would be 30. The next question says, how long is the leg of the right triangle? The leg would be these pieces, and in a 45, 45, 90, the two legs are both the same, so they're both going to be x. And we could actually use our little 45, 45, 90 formula, which is hypotenuse equals radical 2 times the leg. Since we already have the hypotenuse, 30 equals radical 2 times x, we could divide by radical 2, and you're going to get x equals, let's see, we get our calculator, and you can do 30 divided by radical 2, 30 divided by radical 2 equals, and you get 21.2, and that would be in inches. Now the last part is to find the area of the shaded part. So you need to take a half a circle and subtract a triangle from it. So this is 21.2. This one is also 21.2. So you're going to do 21.2 times 21.2, base times height, and then divide it by 2 for a triangle. So 21.2 times 21.2, and then divided by 2 for a triangle. So that's 224.72. So the triangle is 224.72. That was just my base times my height divided by 2. B times h over 2 is my triangle area. The circle is pi r squared divided by 2. We know the radius is 15, so it's going to be pi times 15 squared. So 15 squared, and then times pi, and then we divide by 2. Because we want half of the circle, we don't want the whole circle. So that's 333, or 353.43. 353.43. And when you subtract these two, you get your area of the shaded part, minus 224.72. And you get 128.7. And that would be square inches. That's the area of the shaded region. So your hypotenuse was 30. Your legs were 21.2. Your shaded part was 128.7. Number 2 says Darcy and Joan left work at the same place at the same time and drove in different directions. The angle between their paths was 100. Darcy drove at a rate of 40 miles per hour. So Darcy went 40 miles per hour for 1 hour. That means she went 40 miles. She went 1 hour and 40 miles per hour means she have gone 40 miles during that hour. Joan drove at a different rate of 55 miles an hour. So after 1 hour's time, she would have been 55 miles away. After the 1 hour driving, how far apart are they? So you connect them and you're solving for x. And you need to use law of cosines for this one. This one is your law of cosines because you have little c, you have little a, and you have capital B. So you've got 3 different letters. You're going to need to use law of cosines. And we're going to be looking for little b. So b squared equals a squared plus c squared minus 2ac times cosine of b is my law of cosines formula. So b squared equals a squared, 40 squared, plus c squared, which is 55 squared, minus 2 times 40 times 55 times the cosine of 100. So all of this is going to go into our calculator. So 40 squared, 1,600. 55 squared, 3,025. Now this is where it gets tricky. This is all going to go in at one shot here. But you have to put in the -2. You need -2. If you look on the calculator, there's -2. We're going to multiply that by 40. -80. You're going to multiply that by 55, which is now -440. You're going to multiply that by the cosine of 100. This is the cosine of 100. The cosine of 100 is a negative number. So a negative times a negative is going to give me positive 764.05. Positive 764.05. And that's going to equal b squared. So b squared is going to be what you get when you add those all together. Plus 3025 plus 764.05, 5389.05, and then you're going to square root that to get your little b. So we're going to find the square root of that, which is 73.4 miles apart. The little b is 73.4 miles. That's how far it was from Joan to Darcy. Number 3, one conference room in an office building measures 18 feet by 24 feet. So 18 by 24, that area would be 18 times 24. That area is 432. So it says another rectangular room has the same area, 432, same area, but it's got a width of 16 feet. So we need to know 16 times what is going to equal 432. So you just need to take the 432 divided by 16, and it's going to be 27. So this would be a 16 by 27 room that would give you the same area. So an 18 by 24 room gives you 432. A 16 by 27 room would also give you 432 square feet. Number 4, a deck 4 feet wide surrounds a rectangular pool. So you've got your pool, and then you've got your deck that's all fours. The pool is 20 feet by 15 feet. So the area of the pool is 20 times 15, which is 300. 20 times 15 is 300. Now, this width from here to here is 15 plus 4 plus 4. So that's actually going to be 23. This length from here to here is 20 plus 4 plus 4. That's actually 28. So the entire area is going to be 23 times 28. So on the calculator, 23 times 28, you get 644. So we're going to take the entire area and subtract the pool from it to find out what's left over for the deck. So 644 minus 300, 344 is left over for the deck. Number 5, you want to find the shaded area, shaded region to the nearest tenth. So we need to know, what I would have done first is broke this into 2 triangles. My base is 48, okay, my height is 30. So you have your base times your height divided by 2. You got your base times your height is 30. Base times height divided by 2 for one triangle, and you're going to double it because you want the second triangle. So you're going to take that formula and multiply it by 2 because you got 2 triangles. These are going to cancel out, so really you're just going to do base times height, which is going to be 48 times 30. So 48 times 30 is going to give you 1440. Okay, so that would be the shaded quadrilateral, which is actually like a rectangle or rhombus. So 1440. Yeah, it's a rhombus. They're all 4 equal sides. So 1440 is this inside area here. Now we need half a circle. We need pi r squared over 2 because we only want half of the circle. The radius is half of the 48, which is 24. So it's going to be pi times 24 squared divided by 2. So I need 24 squared times pi, and then divide it by 2. You're going to get 904.78. So 904.78. You need to add these two together. So you're going to get that amount plus 1440. And you get 2344.78. 2344.78. And you look for the closest one. And there it is. It's rounded off perfectly. 0.78 would round up to 0.8. So it had to be letter B there. Number 6, the spraying radius of 5 sprinklers in the right trapezoid yard are shown below. All 5 that are shown have a radius of 8 feet. What is the area of grass for sprinkler A? Sprinkler A has a 90-degree angle. It has a radius of 8. So to get this one, you're going to do pi r squared because we want area. So it's going to be pi times 8 squared, and then we want 90 out of 360. Our fraction is 90 out of 360, and we could actually reduce that to 1/4. So really, we want 1/4 of the entire circle. So we're going to take the pi times 8 squared, 64 is 8 squared. I'm going to times it by pi, and then I'm going to multiply it by 1/4, which is 0.25. Or I could have just divided by 4, same thing. And you're going to get 50.27. So this right here is 50.27. Or 50.3 if we round it to the nearest tenth. What is the length of the arc created by sprinkler D? In other words, how long is this arc? That would be the circumference formula. 2 times pi times radius. And then we want the 42 out of the 360. And that's an easy one to put in your calculator. You're simply going to do 2 times pi times 8 times, we're multiplying straight across. We'll put a 1 out of that if we wanted to. Multiplying straight across, we're going to multiply this by 42. And then you're going to take that whole answer and divide it by 360. And the length of that arc is 5.86. So this is approximately 5.86. And that was feet. This is all in feet. This would be square feet right here. What is the area of grass that sprinkler E can water? Again, area. Here's sprinkler E. So you want the pi times radius squared, that's your area formula, and we want 138 degrees out of the whole 360. So same thing we just did. You're going to multiply straight across and divide by 360. So pi times 64 times the 138. That's multiplying all these straight across, and then you're going to divide by the bottom number, which is 360. Divide by 360, 77.1. Approximately 77.1 square feet of area that they could water. And it's definitely more than this one. This was only 90 degrees. This was bigger, 138, so it's a bigger amount, 77.1. Now, what is the area of each sprinkler, or if the area of each sprinkler were to increase by 20%, what would the new radius have to be? So pick one of my two areas. It doesn't matter which one you pick. I'm going to go ahead and pick the first one. So I'm going to pick the 50.27, and I'm going to multiply it by 1.2, or 1.20 means 100 plus 20%. I want the whole thing, plus I want 20% more. I want it to go up by 20%. So 50.27 times 1.2, 60.32. So 60.32 is would have been my new area. So I plug it into my formula that I used to get this 50.27. I'm going to put 60.32 equals pi times radius squared. We don't know the radius, but what we do know is that the angle was 90 over 360, which is 0.25. So first thing I'm going to do is divide by pi. I'm going to take 60.32 and divide it by pi. It's going to give me 19.2. Okay, so 19.2 equals r squared times 0.25. Then I got to divide by 0.25. So let's see what r squared is going to be. Divided by 0.25. You're going to get 76.8. So this is going to cancel. You're going to get r squared equals, what did I say it was? 76.8? Yeah, 76.8. 76.8. We're going to do the square root of that. Square root of that is about 8.8. So my new radius went from 8 inches, or 8 feet, to now 8.8 feet. So by adding 20% to our area, we would need to add 0.8 feet. If you added 0.8 feet of the radius, like from here you added 0.8 feet, that would make an area that would be 20% bigger. 20%. Number 7. Diagram below shows a circle with a line tangent to the circle. Find the equation of the circle. Your equation for a standard form is x minus h squared plus y minus k squared equals r squared. H and k are both 0. So you're definitely going to have x squared plus y squared. The radius is 1, 2, 3, 4, 5, 6, 7, 8. So the radius is 8 squared. So the radius is 64. So that had to be D. Now the next one says find the equation of the line that's tangent. Okay, we know that a radius and a tangent have to make a 90-degree angle. And we know that if it's a 90-degree angle, the slopes are opposite and reciprocal. So we need opposite reciprocal slopes. We can find the slope of this line. You're going to go up 7.4 and you're going to go over 3. So my slope of this line equals 7.4 over 3. Up 7.4 over 3. You start at 0, 0. You went up 7.4. You went over 3. That's my slope. Rise over run. So rise over run, that's the slope of that line. So that means my new slope has to be the reciprocal of these and the opposite. It has to be a negative, and it has to be 3 over 7.4. So what I would do is I would take 3 divided by 7.4 and get it as 0.41. So it's going to be negative 0.41. That's going to be my x, and it's going to be y equals negative 0.41x plus b. I need to know where it touches the y-axis. Now, if I look at all these choices, there's only 2 that have negative 0.41. And then one of them is saying it touches at 0. Does this line touch at 0? No, it touches at 8.6. So it's going to have to be letter B right there. So this would have to be 8.6. Now you could plug it into your y minus y formula, 7.4 equals m, negative 0.41, and then x minus x formula. And if you do your distributing and solve it, you're going to get y equals negative 0.41x plus 8.6. And that's how you get letter B. Number 8, find the length of AC to the nearest hundredth. AC, I would make a right triangle and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 times 10, so this would have to be 10 radical 2, because it's a 45, 45, 90. Hypotenuse equals the leg times radical 2. So I could simply do 10 times the square root of 2 equals, and you get 14.1. Or 14.14, it says to the nearest hundredth. So that was 14.14. If I wanted to do the same thing here, it'd be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 5, 5, so this is 5 radical 2. You could have done a squared plus b squared as well. 10 squared plus 10 squared equals c squared. You're still going to get c is 14.14. That's not going to change. Same thing here. If you did 5 squared plus 5 squared equals c squared, you're going to get c is 7.07. So 7.07, and it says, what do you notice about these two? Well, the mid-segment is half of the opposite side. So we would say half. Half of opposite side. Half of the side that's across from. This was 7.07, this was 14.14. Double this one, you get this one. Double the mid-segment, you get the whole opposite side. What is the slope of AC? AC, rise over run. I'm going down 10, so this would be a negative 10 for my rise. And I'm going to the right 10, so that would be my run. So it would be negative 10 over 10, which we would reduce to a negative 1. Now, a lot of people put positive 1, but slopes that are downward slopes are going to always be negative slopes. If you read across the graph, this is going down. Slopes that go up across the graphs are positive. The slope of DE is going to go down 5 and over 5. So it's going to be negative 5 over 5, which is still negative 1. So what's true about the mid-segment is that they have the same slope, and if they have the same slope, we call them parallel. So those are parallel lines. DE is parallel to AC. Mid-segments are parallel to the opposite side, and they're half of the opposite side. They're both. That's what this problem is trying to show you. Next one, number 9. Which two equations could we use? Here's my angle. This is my opposite. This is my hypotenuse. So sine 65 equals x over 20. That one could be used. Sine 65, x over 20, boom, right there. Now that's the only one we could use to get x for this 65-degree angle because they didn't give us the adjacent. But you could say that this angle is 25 degrees because they have to add up to 180. This has to be 25. Now you have the adjacent side and you have the hypotenuse. Adjacent hypotenuse is cosine. Cosine of 25 is the x over 20. Cosine of 25 is x over 20. So the sine of 65 is x over 20. The cosine of 25 is also x over 20. It says, what can you say about the sine and the cosine of complementary angles? And this tells us they're both the same. They're both x over 20. So the sine and the cosine is the sine of one angle is the cosine of the complementary angle. That had to be it right there. The sine of one is the cosine of the other. The sine of one complementary angle is the cosine of the other complementary angle. Soda company wants to save money by making their can's volume 8% smaller. Their current can has a radius of 10. So the radius is 10. And it has a height of 25. They want to keep the height of the new can the same. What would the new radius have to be? So right now the radius is 10. We want it to get smaller. We want it to be 8% smaller. So first we got to find the volume of the original can, and that's going to be the area of the base, which is going to be pi r squared times the height. Area of a circle is pi r squared times it by the height. So you're going to do pi times 10 squared times 25. That's going to be my volume. So let's see if we get there. Pi times 100, because 10 squared is 100, times 25. And 7853, let's go 7854, since that'll round up. So 7854 is your volume. I want to multiply this, multiply by 0.92. Because I want to lose 8%. And what's 8% less than 100? Would be 92%. So I only want 92% of it. I don't want the whole volume. That would be 100%. I only want 92% of it. So I'm going to take the 7854 and multiply it by 0.92. That means I want my new volume to be 7225.68. So 7225.68 is going to be my new volume, which is going to be pi r squared times 25. So I'm going to need to move that. So let me write it up here. 7225.68 equals pi times radius squared times 25, because we need the same height. We've got to keep the 25 there. But we want is a new radius. So I'm going to divide by 25 and divide by pi. Divide by 25 and divide by pi. Now on here I'm going to write them together, but on my calculator I'm going to do it separately. I'm going to divide by 25 equals, and I'm going to divide by pi equals. So 92.00 is just 92. So r squared would be 92, and I need to square root both sides. So we need the square root of that. You're going to get 9.6 when you round it off. Your radius is 9.6. What was the old radius? It was 10. All they have to do is take 0.4 off the radius, and it'll lower 8%. It'll make their cans 8% smaller. So people might not even notice the difference, and yet they're saving money by all the cans they're going to show. Now, how much less surface area would the new can have? Well, the surface area is 2B's plus CH for a cylinder. So 2 areas of the base. So 2 of the pi times 10 squared plus 2 times pi times 25. 2 pi r. Oh, 2 pi 10, 25. Sorry, I forgot the 10. 2 times pi times 10 times 25. So now it just becomes a calculator problem. 2 times pi times 100. That's 628.3 plus 2 times pi times 10 times 25, 1570.8. And if you add that to 628.3, you get 2199.1. That would be the surface area for the original can. The new can has a radius. This 10 is going to become a 9.2. So we're going to do the same stuff in our calculator. We're going to do 2 times pi times 9.2 squared plus 2 times pi times 9.2 times 25. So let's see what we would get. 2 times pi times 9.2 times another 9.2. You get 531.8. And then for this one, you get 2 times pi times 9.2 times 25. And when you get 1445.1. And if you add those together, plus 531.8, you're going to get 1976.9. They want to know how much more was this one than this one. Basically, how much are they saving? So 2199.1 minus 1976.9. You're going to save about 222 square feet. Let me think about that for a second. All right, I found my mistake. 9.6 was our new radius, and I put in 9.2, so I need to change that to a 6. I need to change that to a 6. So now let me try 2 times pi times 9.6 times 9.6. We're going to get 579.1. So 579.1. And then we have 2 times pi times 9.6 times 25. 1507. Let's go 1508. So when we add those two together, 579.1 plus 1508, 2087. And if you get rid of these numbers, because they're wrong, we subtract 2199.1 minus 2087.1. You get about 112, which is about 113. So that would be what it would be. All right, how much paper? What I'm going to do, and you already have this on your paper done, so I'm going to pull that out and bring this one over here. How much paper is needed to make a cone-shaped cup that has a diameter of 6 inches and a slant height of 7? So the diameter is 6, the slant height is 7. We just want to know the paper. We don't want to know that. We don't want to cover the top because then you won't be able to put water in it. You just want to know how much paper you're going to need. So you just need the lateral area. And in your notes, the lateral area for a cone was just pi RL. Pi times radius times slant height. So for this picture, the radius is 3. So it's going to be pi times 3 times 7. And you just put that in your calculator. Pi times 3 times 7. You get 65.97, which would round up to 66 to the nearest whole number. So this is approximately 66. And that would be in square inches. Then how much cup will the water hold is when you need your inside height. So you actually need to find this height in here. You need to do 3 squared plus h squared equals 7 squared, your Pythagorean theorem. And you're going to get, subtract 9, you're going to get h squared equals 40, because 49 minus 9 would be 40. Square root both sides, the square root of 40 is 6.3. So the height is 6.3. That's this h right here. So to get the volume of a cone, it's area of the base times the height divided by 3 for a cone. There's 3 cones that would make 1 cylinder. So it would be pi times 3 squared times 6.3. This is your R, this is your H, divided by 3. So again, that becomes a calculator problem. You got pi times 9 times 6.3. And then you're going to take that whole thing and divide it by 3 to get the cone. 59.4. So the volume is about 59.4, which would round to 59 cubic inches. Inches cubed. So that's volume. All right, there's 11. The radii in a pair of circles is a 1:5 ratio. Circles are similar. So your scale factor is 1 to 5. So your area ratio is 1 to 25 because you're going to square both of these to get the area ratio. So if you get a 1 to 25 or 1 to 5 ratio, your areas are going to be 1 to 25 ratio. So if I've got a 78.54, I need to know what that's going to be on the bottom if it's if the area ratio is 1 to 25. So your x is going to equal 25 times 78.54. And you get about 1963.5. 1963.5. A squared b or a prime, b prime, and c prime after a reflection over the y-axis. A prime. Okay, the y-axis is right here. So a prime is going to be 1, 2, 3, 4, 5 on the other side. 1, 2, 3, 4, 5. So 5, 1 would be a prime. B prime would be 2 over. So that's going to be over 2 and up 3. And C prime is 1, 2, 3, 4 over. So 1, 2, 3, 4 over. So that's going to be negative 4, 0. This would be your new triangle if you went over the y-axis. If you folded it on the y-axis, that's what it would look like. If you folded it on the x-axis, then your A prime is going to be 1 above, so it's going to be 1 below. So negative 1, 2, 3, 4, negative 5, negative 1. B prime is 1, 2, 3 above. B is 1, 2, 3 above, so B prime is 1, 2, 3 below. So that's going to be 1, 2, negative 2, negative 3. And C prime is actually going to stay right there because that's the x-axis. So that's still going to be at 1, 2, 3, 4, 0. And so that triangle, if you folded it on the x-axis, would be this red triangle down here. Or you would connect this one, put this one, put this one. Number 16, what's true about the pre-image and the image is that they're congruent. They're rigid motions. They're isometries. They don't change size. They keep the same exact size. They're congruent triangles. If you took a plane and cut through the cone that direction, you would see a triangle. You would see this shape right here. And that's the shape that you would see. Let's see, 17. Okay, we've got our 127. It says, what is the measure of D to A to B? Okay, that is opening up to this diameter, therefore this is 180 degrees. Divided by 2 is going to give me this angle, which is 90 degrees. ADB is this angle right here. That opens up to this arc, so it's 127 divided by 2. That'd be 63.5 degrees. Would be letter angle D or ADB. APB is from A to P to B. That's a central angle. Central angles are the same as their arcs. So this is also a 127. So central angles, APB would be 127. Okay, so you can see the arc still in there. This angle APB right here is the same as 127. So this is 127 degrees. The measure of AEB. AEB is this angle up here. So this arc is 127. So 360 minus 127 is 233 degrees. From here all the way around to here is 233. If I take my big arc, that's your big arc, and I subtract my smaller arc and divide it by 2, that's going to give me my angle. So if I take the 233 and subtract the 127 and then divide it by 2, you're going to get 53 degrees. So this is 53 degrees. You could also say that this one plus this one has to add up to 180. They must add up to 180, which those two do. What must be true about these two is that they're right angles, because they both open up to a diameter. ABC, this angle opens up to a 180 degree arc, and so does the other one opens up to a 180 degree arc. They have to be right angles. What must be true about the quadrilateral? If they're all right angles, it must be a rectangle. Rectangles have right angles. So if they're all right angles, it's got to be a rectangle. And then find the measure, or find the area of DAB. Triangle DAB. So I want this area right here. So I need to do my length, my base times my height, because this is the right angle. So this is your base, this is my height, and then divide by 2. Base times height divided by 2. To get this base, I need to count 1, 2, 3, 4, and 1, 2, 3. This is a 4 by 3. You do 4 squared plus 3 squared equals c squared. C is going to be 5. This one is 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. So 6 squared plus 8 squared equals c squared. C is going to be 10. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6. Yep. And so C is 10. So it's just going to be 10 times 5 divided by 2, which is 50 over 2, which is 25. Let's see. 18. This is my x. This is my y. I want to translate it along the vector 3, 4. So 2, -1, you're going to add 3 and add 4. And you're going to get 5 and 3. Adding 3 is a positive 3. You're adding 4, that's a positive 4. You reflect it over the line y equals 3. You've got the point 2, -1. And you're going to reflect it over this line right here. So right now it's 4 below the line. You got to go 4 above. So you're going to keep your x the same. When you do this, you're going to keep x the same, and you're going to add 4 to my y, your y value. You're going to add 4. So you're going to get 2, still a 2, and it's going to be up. It was -1. Now it's going to be up 4 more. It's going to be 5. No, it's going to be 7. Sorry. 3 plus. This is going to be plus 8. Plus 7. So you're starting at -1. You're going up 4 to get to the y line, the reflection line, and you're going up 4 more. So this is the 0.27. 180 rotation clockwise is just -x, -y. So you're going to do -2, 1. Dilation, you would just multiply them both by 3. So you'd multiply them both by 3, and you would get 6, -3. So this one. And then -x would be a -2. Y plus 3 would be negative 1 plus 3, which is a positive 2. So negative 2, positive 2. So all of those were down here. Could have matched them up. That was 18. A couple more. Which figure could be mapped onto itself after a rotation of 120? 120. Which one could be rotated 120 degrees and land on itself? Well, the green one would have to be rotated 360 degrees because you turn it 90 and it's not even going to look the same. You turn it 90 again, it's going to have the bottom side on the top, which is bigger. That's not going to work. So you need 360 degrees to map the green one onto itself. The black one, you would just need 180 degrees. If you turn it twice, then the bottom side would be on the top, and they would look exactly the same. The red one, you would need 90 degrees. You do a 190 degree turn, and it's going to look the exact same star, or triangle, or not triangle, diamond, that you have. So it can't be either of those. The one that's going to give you 120 degrees is 360 divided by 3 sides, 3 equal sides. If you turn that 120 degrees, that's going to give you a triangle that looks identical. It'll look exactly the same. All right, number 20. We've got a fire here. We want to see which one is closer by how much. Well, actually, we know Colt Station's closer. They want to know how much closer it is. So what is the measure of x? Well, that would be just 75 minus 53. So 75 minus 53. The whole thing is 75. This piece is 53. So what we need left over is 22 degrees. So that would be your first one. Now, if these are parallel lines right here, you got these north-south lines, these north-south lines, and you've got this transversal line. All right, let me get rid of that. This is the transversal line right here. Okay, it says x is an alternate interior angle, or no, y is an alternate interior angle to which angle? So this angle would be alternate interior to this angle. So those two would be alternating sides, and they'd be in between the two lines. So that's 53 degrees. So that means y is also 53 degrees because alternate interior angles are congruent. What is the measure of y? Oh, we put that, 53. What is the measure of angle z? So we know this is 22. This together is 72 plus 53, which is 125. So we need 180 minus 125 minus 22. So 33 degrees is this one right here. So 33 degrees. And then it says, how much closer is this station than this station? So let's find the amount. Okay, so let's say that this is my A, this is my B, this is my C, so this is little a, and we know little a, we want to find little b as well. So we need to find little a and little b, and we have all three angles. So we're able to use the law of sine. So we could put sine of 22 over little a, and the two that we have are the c's. So we're going to have to put sine of 33 over 33. To find out what little a is, we use our calculator. So you've got 33 times the sine of 22. 33 times sine of 22. 33 times 22 sine equals, and that's going to be 12.36. So that's these two, and we're going to divide it by the sine of 33. Divided by 33 sine equals 22.7. So little a is 22.7. Now little b is across from the 125 degree angle. So it's going to be the sine of 125 over little b equals the sine of 33 over 33. We've got to use the same one that we know. So let's plug that in. We're going to do 33 times 125 sine equals, and then we're going to divide that by the sine of 33. Divided by sine 33 equals 49.6 is your B. So 49.6. So I need to take 49.6 and subtract 22.7, and it tells me that this is 26.9 miles closer. This one right here is 26.9 miles closer than this one. So Polk Station would definitely want to be the one to handle the fire. All right, last one is a quick little area one. I gave you the formula, area, and you need to use, you have little b right here, and you have little c right there. So you're going to want to use this one right here. So your area is little b, which is 11, times little c, which is 21, times the sine of angle A, which is 36. Divide that whole thing by 2. So all that is a calculator problem. You put in 11 times 21 times the sine of 36, equal that out, and then divide it by 2, and you get 67.9 when you round it off. That would be square feet. All right, so hopefully this will help you study for your retake if you're going to retake the test.